we have our fully functional quest system, more or less, but now we still need something to show off how far along in the quest we are. We want to show all of the objectives that are available to right now in one of these little tree views, where we can expand any collection of sub-objectives fairly easily. And while Unreal has a built-in tree viewer option, we're actually going to build this from scratch, because I think it is worthwhile to build something specifically for what we need it to do, so that you properly understand how everything works as well. So we're going to need a handful of different widgets that we're going to stack into each other to make this work. We're going to just make a normal widget blueprint here, which will just be a user widget, and that will be our quest tracker or something like that. This is just going to be a general overlay that we put onto the screen for testing purposes. Of course, eventually, if you make this into a full game, this is likely going to be actually somewhere within like a pause menu or whatever. For now, the way that I like to do this is just adding a canvas panel as the base here, and then we're going to be adding 2 borders into that. The first one of which will be in the top left-ish, something like this. And I'm gonna change the brush color to being slightly more gray and then about 20% opacity. Inside of that border, I put a vertical box in which we can put a simple text. I will align that to the center, and this will just say active quests or something along those lines. So now we have a little menu that says active quests. Then next up, we're going to add in a scroll box. And this is going to be a little bit funny the way we set this up. That's also going to be in this vertical box, by the way, under the active quests. And this one we will set to being a vertical scroll box. And then inside of that scroll box, we're going to put another scroll box. And this one is going to be a horizontal scroll box. This creates effectively a scroll box that will be able to scroll in both directions. This is mostly relevant for if you have a long list of quests, and then also quests that go a lot like in depth with a lot of layers, because every single layer with sub-objectives in it is going to be offset ever so slightly to the right. So if you get a lot of nests in, eventually you're going to go off the right side of this border, in which case we want to be able to scroll. Of course, if you're making a menu where that's not an issue, you don't really need to do this. And within there, we're going to put in one more vertical box. And that's the basic layout for how this is going to work. So you could make this into its own sub blueprint as well, if you really wanted to. Because what we're going to be doing is we'll copy this entire setup over to the right side of the screen as well. Again, this is mostly for troubleshooting purposes. We put the anchor in the top right and we change the text to finished quests. So when we get a quest, it's going to be added to here. And then when we finish it, it's going to be added to there instead. Now, how do we actually display the quests themselves? Well, for that, we're going to need a handful of other widgets. So let's take a look into making those. The most important of which is going to be a user widget as well. That will be our objective viewer. This is effectively going to be the custom tree viewer that we're going to be making. I will just open that up real quick, but we're not going to do too much with it quite yet. We will very simply just add in a vertical box, and that's going to be all we have for this right now. Because in order to do anything with this, we're going to need to make our quest text, the thing that actually shows the name of every single objective in our quest. So we do that by making a user interface, and this will be quest text, just as easily as that. And this is the first one that we're actually going to build out, because once this is built out, we can then go back into our objective viewer and implement everything about every single quest text that we'll create very, very easily and very simply. So the quest text itself also is going to start with a vertical box, because we're going to be stacking a couple of things on top of each other. I will set this one to desired on screen just to have a better preview of how big everything is. Then we'll start by adding in an overlay, because we're going to have a couple of things parented to the same thing here. The most important of which being a button. So let's put a button into the overlay here, and that's going to make the entire overlay clickable. Let's go into the button though and go to the background color, and we'll set the alpha for this to 0 so that the button actually is invisible but still interactable. We just can't see it. Of course, if you want the button to be visible because all your quest text needs to have a certain look to it, feel free to do that. I like just having the plain text a little bit more. Then, under the button, we'll add in a text block. So now the button is effectively just the text. Anywhere we click on the text will be fine. Important to note though is that the button does need to be set to fill horizontally and vertically, so that it's actually as big as the text. And then we can add a progress bar, not into the overlay itself, just into the vertical box, so that it is added in under the text. And this is the layout for how every single individual objective is going to be implemented. So let's go into the event graph and actually set some things up here. The most important of which is going to be the button. We want to add the onClicked event for that button. And we want to add an event dispatcher to this, and we'll call that something like toggle collapse, something along those lines. And when we click that button, we're going to just call on toggle collapse, and we'll implement the actual logic for that in another place. But now we have a way to toggle it between collapsing and being uncollapsed. Now, event construct. We don't need event tick necessarily, and not even pre-construct. We only need event construct at the moment. We want to go back into the designer and make sure that our text is set to being is variable. And while we're at it, we might as well do the same thing with the progress bar. Just check whether or not it is set to variable or not. And then we can pull in our text block and we can set the text, which you can either do directly with the variable or with set text as a function. And we're just going to promote that to a variable. We can just call that inText. That is actually a perfect name for it. We'll mark that as instance editable, but also expose it on spawn. And now we're going to do, but how do we now get the text for this? Well, the way that we're going to do this is we're going to add in another variable, and that will be our objective that we're going to be displaying every information about on this thing. So that will be a base objective, which still will be able to take in things like a objective collection, but we'll only be able to access things that are on the base collection, which we will make instance editable and expose on spawn. So whenever we create one of these text quests, we need to give in the objective that is going to display. And with that, we can get the objective name, and that is going to be our text. Then we can also get whether or not it is completed. We don't really need to worry about it being active or not, because we'll do a little bit more about that in a moment. But the reason that I want to mark this as completed or not is because I'm going to kind of change around the text, specifically the text color. I want the text color to be a little bit more of a dull gray, showing you that you've completed a specific task. So let's get this text block, and if completed is true, we want to set the color and opacity. So set color and opacity. And let's just make a slate color, and here we can just create whatever color we want. So what I'm going to do is I'm going to set the saturation to nothing, and then we're going to set the color to being a little bit more of a darker gray, meaning that if this is true, we set our color to this dark gray instead of the pure white. And then also, once this thing has been completed, I don't think we necessarily need the progress bar for it anymore. So we can set the visibility for the progress bar to change to hidden. Then let's go back. That is if our task is completed. But if our task is not yet completed, we need to set some other stuff up. So we need to figure out whether or not this task is supposed to show a progress bar to begin with. Because some tasks we might not care about showing a progress bar for. So we made a bool for that, a show progress bar. So let's get that. And we can do another branching node there. And there is actually fairly easy. If show progress bar is false, we just hook up to this, set visibility to hidden. If it is true, however, we want to set the progress of the progress bar to match the completion rate of this specific objective. So let's get our completion progress, which is a function that we made on the objectives. That gets us a float value, which is going to be between 0 and 1. So we can just use that for our progress bar to set the percentage, which is a 0 to 1 value. And that effectively finishes off the quest text that we had to create there. So now it's just a matter of instantiating a bunch of these for every single quest and every single objective that we currently have active. And that is where we finally get back into our objective viewer. This thing is going to be rendering everything to actually show those quest texts. And there's going to be a little bit of a mess as far as nodes go here, so stick with me. Let's go into the event graph, and on event construct, we're going to do quite a lot of stuff. So this objective viewer is going to take in individual quests. So we're going to instantiate one objective viewer for every single quest that we make, meaning that it's going to be taking in a collection of objectives. Then the quest tracker itself is going to be responsible for providing multiple different quests in, if that makes any sense. So the very first thing that we want to do here is make a new variable for the objective that we're going to be creating this thing for. This can be either just a normal objective or an objective collection. So the type will just be base objective, but we're going to be checking whether or not it is an objective collection. So we'll mark that as instance editable and set to expose and spawn, because we'll populate that in a moment. But then we'll pull this in. And the first thing that we do before anything else is we cast to objective collection. So this way we will know whether or not we're working with a singular objective, any children of the single objective, or specifically an objective collection. Because if it's an objective collection, we need to then spawn in multiple other objectives as a child of this. But if it is a single objective, we know that we've kind of reached the end of a tree. Do be careful with everything that we're about to implement though, because we're going to be spawning objective viewers within this objective viewer, which can, if you make mistakes, lead to an infinite loop. And Unreal doesn't like potential infinite loops. So I was going to complain at you about that if you make any mistakes. The very first thing that we do is we're going to skip over these two pins here. These are going to both have some stuff going on for them in a moment, but that's a little bit complicated, so we'll save that for a little bit later on. We're going to check a bool here. So we're going to get the objective again, and we're going to check is active. So we'll just get is active, because if somehow we're trying to render an objective that is not currently active, we don't need to show that. Of course, if you want to, you can still add them in with maybe a different color or like a different material applied onto them. For now, things that aren't active, we're not going to add to this tree view at all. So only if is active is true on the objective that we're trying to render here will we actually move on. And what we will do is we will create a widget. And the widget that we're going to be creating will be a simple quest text, which takes in an objective, which is going to be the objective that we're working with right here. Then the output of that we can add in to our vertical box. So if we go back into the designer, we make sure that our vertical box is marked as a variable. We now have it accessible in our blueprint. We can add a child, and the content that we're going to be adding will be the return value of this create quest widget text. So that will be getting added to the vertical box now. And what we're actually going to do here is we're going to take our cast and we're going to move it a little bit later into the event graph. So we will start off with checking whether or not it is active and then doing all this. And after all that, we'll do the cast, because here we need to decide whether or not we want to spawn in another one of these objective viewers. We don't need to decide that until this point. Until this point, everything just works the same. It's just after that will the paths diverge on what to do. Because if this cast is successful and we're working with an objective collection, we then want to get the text widget thing that we just made, and there we want to bind to our on toggle collapse. Of course, if this is just a singular thing, we don't want to be able to toggle the collapsed state of it, because you don't collapse a singular objective, only multiple objectives. So that's why we do this casting here real quick. And there we will just make a custom event for it, and we'll call that toggle collapse state or something like that. And now we might need to go back into our objective collection real quick to add a variable that I haven't added before. So let's do that. Go into the objective collection, and we have another thing here. This will be a bool, and we'll just call this a collapsed or something of the sort. So the object itself is going to keep track on whether or not it should render as being collapsed. As a general rule of thumb, UI elements shouldn't really decide a lot of stuff. They should only be reactive to the actual object's information. That way you're going to build your most scalable and most easy to work with systems. let's make sure that we have that compiled and go back into our objective viewer real quick. Because now with that, we can get the collapsed variable and we can then set it again. So set collapsed variable, and we're going to set it to being the opposite of what it currently is. So the easiest way to do that is to get a not boolean of the current value. That's just gonna, if this is true, it's going to turn it into false. And if it's false, it's going to turn it into true, which means that we can easily flip the value of it like this. The reason also that we want to store that on the object and not on the UI element itself is if the UI element gets removed or it gets refreshed, it's going to go back to its default value. The object itself will be able to keep track of things. So that way, if you have a submenu that is opened up, but you collapse its parent and then you uncollapse the parent, the submenu itself will still be entirely opened up. And then we're going to add an event dispatcher here, and we'll just call that objective view updated or something like that. And we will call that out because if we toggle the collapse state of something, our objective view will have been updated and we need to re-render some stuff. Now, after that binding, we want to add in a branching node, and we're going to check if currently we are collapsed or not. Because if this thing is collapsed, we don't need to add in any other subviews because it's collapsed. So that kind of takes care of that. But if we aren't collapsed, that means that we're supposed to show all of the sub-objectives of this objective. So what we need to do at that point is we need to, from our objective collection, get all these sub-objectives. So get sub-objectives, and we're going to for each loop over all those. Again, hook that up to the full spin of our branching node. And for each one of those, we're going to create a new widget. And the widget that we're going to be creating will be the objective view. So objective viewer. Again, this can be a little bit tricky because we're creating more objective viewers within this objective viewer, all of which can potentially create their own set of new objective viewers infinitely on and on and on. So do be careful with doing this. But it's just going to take in the objective for each one of these sub-objectives, and then we need to add that to our vertical box. So we add those to the vertical box. We just add child for each and then each individual one of these. And after that, the thing that we get back out of adding a child is a panel slot object reference. That is the actual information on how this will slot in to our vertical box. So in our case, we know that this is going to be a vertical box slot. So we can cast to vertical box slot, and that will give us the opportunity to set the padding information for it. And this is going to be the way that we set the offsets for each layer of nesting. So we can split that structure pin. And what we'll just do for now is we set the left padding to 20. So each layer of our system will be offset by 20 pixels to the right. So we can have like a objective that has a couple of sub-objectives. And if any one of those sub-objectives has its own sub-objectives, it's going to offset those. And if any one of those has its own sub-objectives, it's going to offset those, and so on and so forth. So it's going to create like this diagonal system. And then the very last thing that we need to do is for every one of these objective viewers, we have a objective view updated, and we're just going to bind to that. So objective bind to objective view updated. And the only thing that we need to do there is a custom event. We'll call that forward update because it's just going to forward the update into the next layer. Again, much like we did with the actual objective collection itself, if we go back to this example of having a couple of layers worth of objectives, right? So we have this layer, which is a sub-objective of this layer, which is a sub-objective of this layer. When this one here gets updated, it's going to send its message forward to this, which is going to send its message forward to this. And again, this can infinitely stack on top of each other. And that, for the most part, is the functionality for the tree view that we have just created. So as a quick overview, we check whether or not something is active to begin with. If so, we add a quest text with the name and everything that the quest text itself fills in here. We'll get back to this in a moment to make this a little bit more neat and a little bit more complicated. Then we'll add it to the vertical box. Then we check whether or not the objective that we just added is an objective collection. because if it's not, we're just done. There's nothing else that we need to do. But if it is, we want to make sure that we can click on it. So we bind to the toggle state collapse, which will toggle the collapse state for it, let our system know that something was just updated. We want to check whether or not this collection currently is collapsed or not, because if it is not collapsed, that means it is opened up. And we want to add more objective viewers as children to this that correspond with, again, each one of those is going to run here from the beginning. Going to just add them if they are a singular objective. Going to check if the objective that we just added is a sub-objective or has sub-objectives. And then when it gets to this, it's going to loop around until it finally gets to the final layer, which is going to be just singular objectives. So with that, let's go into our quest tracker and make sure our quests for active and finished are added to this, which is remarkably simple now that we have everything else set up. Let's make a separate event for this real quick, shall we? Because we can just make a custom event, update quest lists. This could be 2 separate events, but I'm going to do it with just one. For the ease of reading everything, I'm going to break them up into a sequence node, because updating the active quests and the finished quests effectively is the same code with just a variable swapped out, which is why you maybe want to look into making that its own little sub widget, of course. But the first thing that we're going to do is I'm going to get the scroll box from this one, and I'm going to make sure actually that it's a variable, and then we clear all the children out of it, because we're going to, every time we update the quest list, we're going to redraw everything from scratch, because that's just the easiest way to make sure that everything is up to date. So we first want to get rid of all the old information. Then we need a reference to a quest component. So let's make our quest component. We'll set that to be a quest component object reference, which I'll just set to instance editable and expose on spawn. You can just get this from player character and get quest component with the interface that we made. I like doing this a little bit better because it's slightly better form. And with that quest component, we can then get the active quests, from which, of course, we can get the keys, which we can use to run a for each loop. Now, this is a little bit funky because you can for each loop over a map in this way. If you get the keys and you do a for each loop over the keys, you can then use the map's find function to find that key in the map and then get the actual, like, in this case, object out of it. And for each one of the quests that we can find, we're going to be adding a new widget. So we create a widget, and that widget itself is going to be a objective viewer, which of course needs an objective, but we can provide that in because we have our quest here. So we can get the objectives, because it's a variable that we have on our base quest, and that we can provide into this. So again, this is going to run all of that like recursive code that we made here on the first set of objectives. And then if there's any objective collections within those objective collections, within those objective collections, within those objective collections, it all takes care of itself. We, of course, then take this scroll box and we add that objective that we just created as a child. So we hook that up into the contents. And then the update quest list event that we made here, we will actually bind to that update event dispatcher that we made. So we can bind to onViewUpdated. And whenever the view is updated, we're going to just run this update quest list. So any of the things that we are instantiating and creating and adding as like children to all these boxes, they all have their little signal like, hey, I just updated, I just changed. That's going to send its signal all the way back up to this quest tracker widget, which will rerun the update quest list, which will first clear everything out and then just new up-to-date versions of everything. That's on a very large scale, not necessarily the most performant way to do this, but it is very much the easiest way to do things. If you want to be a little bit more performant, what you do is you only reconstruct the thing that actually changed, because right now we're also reconstructing a bunch of things that didn't actually change. So that might be something worth looking into at a later date. And then we can pretty much copy all of this over and we'll just change a couple of things around. So we make the other scroll box over here also a variable. And then we can just plug that into everything that has a scroll box in the bottom here. So that's these two things. And then instead of getting the active quests, what we'll do is we'll get the finished quests and get the keys from that and use the finding on that. And that effectively, I think, changes everything around properly. So we can also hook this up to the unupdated quest list. Also, probably a good thing to make this into 2 separate events so that it doesn't redraw both every time something changes in either. There is a little bit of CPU optimization to be done with this for sure. But with that, I think we are effectively finished up with all the UI stuff, which it takes a while to set up, but then we should never have to look back at it ever again. So let's go into our third-person character and wherever it might open, there we go. And on begin play, I'm going to just real quick add in a create widget. And that widget that we're going to create will be our quests tracker that takes in a quest component, of course. That's going to be the quest component on this character itself. You can also add this directly to the component if you prefer. Kind of depends on how you're implementing this and if you're doing like multiplayer and stuff. A lot of things that I'm doing here aren't necessarily ideal for multiplayer related stuff, but this is the easiest way to do it. Otherwise, what we can do just to keep things a little bit more scalable is go back into here and in event begin play in our components, do all that instead. And if you do that, the quest component reference can just be self because we're now inside of a quest component. Either way, what you want to do is after creating the quest tracker is real quick update the quest list. This is going to not really do anything at the moment. We'll add this. We'll also get rid of these print strings actually. At the moment, this is not going to do anything, but later on, we'll add a saving and loading system. So we want to update the quest list immediately after we load some stuff as well. So that's why I'm already adding this in here, just as a little bit of future proofing. Another reason that it might be nice to do this within the component is because we're going to need to hook up a couple of things to functions that we made previously inside of this component. So after we create this thing, it'll be good for us to promote this to a variable. We'll call this something like quest UI, so that we can access it easily in all of these different functions. Because when we add a quest, obviously, we're going to want to run that update quest list. So first and foremost, let's go to add quest. We already have a couple of nodes ready and waiting for us. And he will need to bind to whenever this quest gets updated so that we know to redraw some stuff. Again, this is part of the reason that I'm just redrawing everything so that we can share one function across a lot of different uses. So for this, we will need to go to our base quest. And we need to add in another event dispatcher because at the moment we only have a quest completed, but of course we also need a quest updated whenever any part of the quest itself, any of the objectives send over an update, but the quest isn't quite completed yet. We want to run quest updates. So on start quest, we bind to update objective as well. And this update objective is just going to make a custom event here real quick, update quest. And that's just going to call out quest updated so that whenever any of our sub-objectives are updated, it'll also update the quest as a whole. And now that we have that, we can go back into our quest component on the add quest function. The quest that we added, we also want to bind to quest updated. I like to do it before starting the quest because if we do it beforehand, it'll also immediately implement the update for the initial start of the quest itself, meaning that it's going to immediately show everything on screen the moment the quest starts. So from this, let's create an event and we create a matching function, which we'll call something like update UI. And update UI is just going to take our quest UI and it's going to update that quest list. Then in our base quest, in the start quest event still, we get our objectives. From there, we get our sub-objectives and we do a for each loop over those so that we bind to the completion or the updating of every single one of these. So the way we do that is we bind to update objective and then we also bind to finish objective just to be sure. So let's update objective event or something like that. And we just call on quest updated with this. And at the end of the for each loop, we also call on quest updated because now the quest is completely started to initialize. So that is when we want to call out quest updated once fully. This also needs to be hooked up to this objective event. That's my bad. So that it can be added to our UI. And the last things we need to make all of that work is to go into our base objective and going into activate objective and adding a call update objective. So just update objective and call that out so that whenever we activate any individual objective, it also gets sent out as an update because, of course, activating it means we've changed some data about it, which means that everything listening out for updates needs to be aware of that. And then in our quest component, we have our quest complete, where we move the quest that we just completed from the active quests into the finished quests, but there's nothing that's really like broadcasting that as an event. So we're just going to get our quest UI variable and update quest list from that to force it to update the quest list after we change a quest from one list to the other one. And that means that we have a quest thing. I enabled the progress bar for the topmost quest that will set your first quest, walk into the circle, walk into the ramp, and then we need to walk up the stairs, and then it's added to our finished quests instead. Now, the progress bar doesn't quite work yet, and that is because in our objective collection, I don't think we are actually overriding the get completed percentage. But that's actually very easy to do. So instead of using our parent function, we're going to write a quick little implementation for this, where we will get our sub-objectives, we will for each loop over those, and for each one of those, we will get the completion progress, and we will be dividing that by the length of our sub-objectives array. So we can just get length, divide that like this. You might want to put a toFloat node in between just to be sure. The return node here, we're going to just put away for a moment. And then we'll make a local variable called the complete rate. And that's going to be a float, which we're going to set to the complete rate plus whatever the result from that calculation is. So this way we get the completion percentage from all our subtasks, which will get that completion percentage from all their subtasks and so on and so forth. And then we divide them by the amount of subtasks that we have so that it only gets to 100% or a value of 1 when all the subtasks have all their subtasks completed. So we do completion rate plus the result of that is going to be our new completion rate. And then once the for each loop is completed, we will return the completion rate value. And that's the only thing that we needed to make the progress bar work. So now we can see as we progress through our quest, our progress bar will update in increments of 1/3. And then when it is completed, we get rid of it because we don't really need it anymore. That's been a long and in-depth video about making our tree view. In our showcase here, we have these little icons here. So there's a little arrow icon that becomes this downward arrow icon. And whenever something is not collapsible, it just has a little dash. Let's implement that real quick as well. We're going to do that in the quest text, and there's gonna be quite a bit to do here. So let's try to make our way through this really quickly. So we first want to check whether or not our objective is a objective collection. So we're going to cast to objective collection because we're going to do this in 2 separate ways. We'll take our objective name and we're going to disconnect that real quick because we're going to be making a variable for this instead. And the variable that we'll be making will be a text to display, which can be a text variable, that's fine. And we'll add 2 different setting nodes for that. So if the objective is not an objective collection, what we'll just do is we'll get the objective name. We will make a string out of that real quick. So we do a toString so that we can append it. And what we're going to append it as is the A value will be a minus sign and then a spacebar. And then the B value will just be the name of our objective. And then we can do a toText string again to set that as the text. You can just make this a string variable as well if you want to. There's no real use in making this a text variable, but in the end, it doesn't really matter. And then we're going to go to the setText node. We'll do the text to display as the input for the setText node. Now, if this is an objective collection, this is going to be slightly more complicated, but not by that much, honestly. So what we'll do is we'll do another one of these append nodes, where we will append the objective name, but instead of just doing it with a dash, what we'll do is we will get the collapsed state from this thing, and we'll actually use a select string node. So this will allow us to append one of 2 different strings. So if this thing currently is collapsed, we're going to do the little right arrow thing here, And if it is folded out, so uncollapsed, we're just going to do a capital V, because that effectively looks the same. And that's going to go into the text display if the cast was successful. And then that also goes into the set text. So just as easily as that, and in both of these cases, I guess you also actually want to have some white space next to them. But as easily as that, we now have those little things also showing. So as you can see, this is now by default, everything is uncollapsed. I guess going into the objective collection and setting the collapsed value by default to true might be nice. So now by default, when a quest is added, it is collapsed, and you need to have your input mode set to like UI and be able to click on it and that kind of stuff. But that's quite besides the point. Just it works now. Let's just in the quest tracker add in like event construct. We'll just set input mode to game and UI, and we will get player controller as well. And then we will show mouse cursor real quick, and we'll set that to true, just so that we can interact with things a little bit more easily. And of course, plug it into the set input mode as well with the player controller. It's quite important. And quite important is to select your text and go into its visibility settings and go from visible to being not hit testable, self only. Otherwise, it's going to be blocking your ability to click on the button behind it. And now we can pick up the quest and click on this thing, and because it has the button inside it, it registers our click and uncollapses just like that. And of course, we can just go through, do our quest things, we can collapse it at any time, and then uncollapse it, and it will remain with all of its information. If we have any sub-collections in here, those will also remember their own collapsed state. So that's been quite a bit for this one video. I might have actually ended up cutting it into 2 videos. We'll see if I can find a good cutting point that makes sense. It's probably just going to be one long video. So I'm going to shut up now. If you want the project files for this entire course, the finished course, of course, as always, has a project file download below for patrons and YouTube members. And each individual episode also has a project file download. With a long video like this, it might be a good idea to take a look at those. And for the full course, if you're watching this in the future, it should be all up on the YouTube channel already. But if you're watching this shortly after it was uploaded, there will be a link down below in the description to the Patreon where you can find the full course. And a very big thank you to all of my Patreons. You can see them on screen right now. If you want to help out supporting the channel, there's a link down below in the description to the Patreon page. A huge thank you to my Cave Digger tier supporters, Sir J. Thomas,